Hi, I would like to update you about the free parking visualization tool, which was a GSoC 2020 project for this summer. The aim of the project is to build a mobile and web application to identify the number of free and occupied parking spaces in public parking areas. The use case in this project is applied on the parking area in Yeida Scientific Park. So first, I would like to start with the plan which we had, the task which we had to complete for this month. First, was to extract videos from the security cameras, from the scientific park security cameras, and manually set the parking regions to train the object detection model, and then to also design the UI of the mobile and web application. So I will go now to what we did in the first week. So in the first week, along with my mentors, I checked the accuracy of different object detection models available online, and I checked different models such as the faster RCNN, SSD MobileNet, and checked the precision of these models with respect to detecting cars from videos and data sets that I found online. And then we decided that we would try the YOLO V4. So then we tested the YOLO V4 on different car videos that we downloaded from publicly available sources, and the YOLO V4 model works extremely well, and hence we decided to go ahead with that model. So to go back to the data architecture, the project architecture, the idea was to have videos from cameras and then set parking regions, and then use the YOLO V4 model to extract images and detect cars. And then the backend of the to build two of applications. One is the parking admin tool, and the other is the mobile application with React Native. Um, and we are now working on the back end. So I will go through the first part, which was setting parking regions using the object detection model. So then I set the parking regions manually using Matplotlib, and selected different polygons for the parking areas, and then stored the coordinates of the parking areas from the image in a file, the regions.p, and then use the YOLO V4 model for detection, which is basically cloning Alexei AB's darknet and setting all the makefile configurations, and then defining helper function to display the images and save the files on Google Drive. And then this was done using the pre-trained Coco dataset, which is available already. And once we mount the drive and authorize using the email ID, I created a symbolic link so that it would be easy to access the contents. The test images are stored in the drive in the images folder, and in this case the parking regions appear like this. So as I said already, I already defined the regions.p to contain the coordinates of all these parking areas. Now we run the model and see how the results come across. So then we see that most of the vehicles here are detected and the model works really well. Now the further step is to consolidate it and find out, print out the empty parking regions. The approach that we used for this is by finding out the centers of these bounding boxes from the object detection model and then seeing if they lie within the polygons predefined in the regions.p parking file. So then I go ahead and talk about the functions written for the same. So I first import all the required packages and then load the regions.p file containing the shape polygons of all the parking regions. And then now I also define a function to compute the centers of the bounding boxes detected by the object detection model, and then write a function to see if it falls inside a given polygon or outside. And then we see I then write another function for checking the overlap. This function also counts the number of vehicles in the image and in the entire image. So then the ones which are occupied for now, I fill the polygon to see how many occupied spaces are detected. And then when we run it by calling the YOLO v4 model and display the image, you can see that it detects some of them. Although the model detected all the cars in the image, only a few occupied parking spaces are printed. This is because of the approach. Then we realize that the centers do not overlap because of the camera angle. And so now we are thinking of new ways to solve this issue and other approaches by which we can print out the parking spaces more efficiently. The free parking spaces are just the set difference of this. So now once this is done, the idea is to use the back end to display it on the mobile application. First, I will show you the UI of the mobile application and the web application design. The web application is still in design form. The idea is to display all the parking areas and then have all the statistics for the parking administrator to view, the total capacity, the occupancy, number of free spots, and have a refresh frequency on this. And I will show you the mobile application now. It looks something like this. This is the home page. You can see this is built using React Native framework. You can see how much is occupied, and then users who are regular can also sign up, and they have to fill in few details so that the data can be collected, and select vehicle type, because we can also then visualize the reserved parking spaces for electric vehicles and handicapped people. And then the idea is to, when the user clicks on view parking spaces, the image that the model calculates is then rendered along with a few key statistics for the user. So this is the UI of the mobile application, and there's also an about page which talks about the project a bit. So now regarding the next step, it was the backend. So I set up a web server and a REST API which is now running within a Docker container on Docker Hub. So as you can see here, this is a simple response that is printed off the sign up page. The plan for the next few weeks is to finish the development of the mobile application and the backend and have the entire thing running, to refine the approach for printing the occupied and free parking spaces, and thinking of other ways to do it apart from the center lying within the parking polygon, and then extrapolating this and using the TF light, TensorFlow light model for rendering the image in the mobile application, and then integrating the application with the Liquid Galaxy. And if time permits, development of the web application UI as well. So this is the plan for the next few weeks. And yeah, I would like to conclude my update. Thank you.